I'd like to thank Maya for this informative presentation that she did. And now we have, like the digital inclusion suggests, now we have a speaker from Romania, and see how inclusive we are. We are here in Slovenia, but then we are hosting a speaker from Oral University from Romania. This is Marius Balas, who's going to present his work on the Moore's Law for Education and the need for inclusion. Okay, very good. Marius, your voice, I guess?
Do you hear me?
Oh, yes, very good. Thank you. Marius, excuse me, you have 15 minutes to talk and 5 minutes for the question and answer session.
Okay.
Thank you. Please.
Okay. I'll try to share my presentation. I hope you see it. Can you see the presentation?
Okay.
Okay.
There you go.
Well, first of all, please accept my greetings from Arad. I'm sorry not to be able to join you, but perhaps in the future, who knows? Well, our work, it's about a category of people which seem to be now in trouble, which need help to be included in our very dynamic society. So it's about students, most of all at the bachelor level. So what is happening? You see, many people know about Moore, Gordon Moore, and he formulated a very, very famous law. The number of transistors in an integrated circuit doubles every 2 years. But in time, this law began to be applied in many other fields. You see here, for instance, diagram about more than 100 years of Moore's law. So this law can be applied in general to the technological evolution of our society, not only in electronics, and even more. You see, a Moore's law for knowledge was formulated in 1981. So the general human knowledge doubles every 12 months each year. So the last step was the Moore's law for everything, which addresses the entire society. Well, problem was that the education was not so suited to follow this rhythm, this pace. So in 2001, Gordon Moore complained it's hard to come up with ways to increase productivity in education. So nowadays, people are becoming aware of this issue, of this problem, and solutions are beginning to show up. We will propose such solutions, but as if I dare to say, more radical than the usual mainstream. Well, my personal motivation in this field was very old. Already in 1979, at the Club of Rome, it was a report. One of the authors was Mircea Malițar. He was Romanian, and the idea was that there are no limits to learning in a world that has is bounded in any direction, resources, space, you name it. Still, the education has no limits, but we need new approaches, we need new visions to extend these boundaries. Now, our main specialty, it's in the field of system engineering, and I think that system engineering it's a discipline that is coming with the complexity and the growth of society in any direction. So we can find in this discipline a lot of solutions that could be extended to many fields. And now we are trying to apply the top-down approach, which is common to the system engineering in education, if possible, and it's possible. Well, the problem is that the society, the knowledge, the volume of knowledge of our society is increasing constantly in an exponential rate, while professors and students remain mainly in a traditional frame, and it's difficult to change this activity. And the final result of the problem is the school dropout. Many of our students, let's say, school dropout was always a problem, but now in these last years it's growing, and not only Romania. I have signals that in all over the world this is an issue. So why it's happening? Why this? Look how it was the traditional style of presenting knowledge. For instance, Todor Mommsen, who wrote the history of Rome and got the Nobel Prize for this, you see some pages of his work. Well, a little bit dull, perhaps. Look here, it's I present you, I show you a work of a painter from Arad, Onisim Colta, about how knowledge is growing, and we must do something. What can we do to fight the school dropout? And I think the most of the problem, we teachers, professors are responsible in the end for solving this problem. It's less the task of students than ours to try to improve things. And so we were thinking about solutions, and look what systems engineering has to teach us. It's a top-down approach. Now, about system engineering, perhaps you know more or less about this, but it's a fundamental discipline which is growing these years, and it's issuing from Bell Telephone Laboratories, which invented electronics, and from NASA. Here it's Werner von Braun with the Apollo program. Now, what is this top-down approach? The basic idea is that the system as a whole may greatly differ from the sum of the parts properties. So system engineering is embracing a holistic view, and then it's very interdisciplinary, because disciplines are now beginning to cooperate, to melt. So these are the two features of system engineering. And this top-down approach is not very common. Our first idea would be the bottom-up approach, and this comes with less details, which is well, it's not good, it's not an advantage, but it's coming again with more comprehension, and we have the chance to observe fundamental solutions if looking from a distance of any phenomenon. So how can we apply this in system engineering? First of all, I present you a solution which shows that the truth, the most valuable view, must embrace both approaches. So in the very well-known hardware description languages, which are now the main tool in electronics, we have a software that allow us to describe, to represent a circuit, but there are two different views on the circuits that they are perfectly compatible and they work together. The behavioral one is presenting the functional aspect of the circuit. So it's like a top-down approach. The architectural view, is a traditional one, rather. It's presenting the architecture and the solution for implementation. But these views must coexist. And in education, I think the top-down approach was not so present. It was present, of course, but not so underlined. Now, the bottom-up teaching is beginning with component, with parts, and growing and going up. But this approach, which, for instance, in a foreign language, will start with grammar. This approach it's rather time-consuming in the end, so it's not effective. This analogy, this can come with an analogy with the architectural description of a circuit. While the top-down teaching begins with a larger view of the subject, gradually descending to the building blocks. And this is, well, analog with the behavioral description, and it's further more effective. I remember that my professor, my mathematics professor in the high school, was beginning a new lesson with a problem which normally we couldn't solve it because we didn't know the theory. But in 5 minutes we were looking to that problem, and then when he was beginning to teach the lesson, we had idea of the objective of this lesson and of the finality of this, and that was very good for me especially. I'm not very good in mathematics. So this approach is very fast and very effective. This is coming together with perhaps with the method of studying scientific papers. So the most effective approach is to read the title, then the abstract, and then to jump to conclusions, and only if these conclusions are relevant for us, only then we will come to the paper, to read it and to study it. So this way we can save a lot of work and skip things that are not interesting. Now, other concrete inclusion measures, this is beginning to be more and more interesting. Well, but before presenting our ideas, we must mention that this phenomenon is present in today's psychology. So we found at least 3-4 papers which are, and not only papers, ideas and parties that are dealing with this issue. Now, for instance, John Sverre's cognitive load theory addresses the challenges posed by exponential growth in knowledge. So in the end, he proposed to simplify the complex information and to utilize multimedia tools to present knowledge visually. Here you see another approach, self-determination, which emphasizes the essential physiological need of autonomy and competence to be offered to the students. So the motivation and the self confidence are helping them a lot to deal with bigger and growing amount of knowledge. The information processing theory, it's providing information and knowledge about how information is encoding and retrieved by our brain. And they are, for instance, proposing to chunk a bigger subject in parts, in smaller parts, and rehearsal, like Shannon said. Yes, and well, there are some other methods, and then there is a current of papers and well, it's a way of thinking in psychology to try to adapt to the system theory. So the complex adaptive system theory provides a contemporary cognitive psychological perspective that integrates concept to systems engineering. So this having been said, our observations, well, it's not our, I just found a paper in which they showed a famous test given to a year of students, to a group of students. This group of students was halved, and half of them received the regular test, written text as text, while the others received the same questions but doubled and helped with images and figures. And you see the results are spectacularly different. So the students that received not only text but also images managed to have a almost twice performance comparing to the first group. And that is because we are a daily diurn species. Our informations, our brains are oriented to process vision. You see here, the visual information is processed 60,000 times faster than text. Text, it's invented 2,000, 3,000 years ago. Our vision it's from the beginning. So it's obvious that visual knowledge can be processed easier and faster by any human, students included. Now, in systems engineering, we work with a lot of diagrams. Complex systems cannot be represented in text, in analytics, in formulas. You see, this is how it's working. And there are now a lot of software that is providing this kind of visual tools. I think this experience should be extended to other fields too. These are some works made by students. They like to work like this. They never cheat. when I give them a test or projects with the UML language, for instance, they like it and they work independently, and well, it's something familiar, especially to the newest generations. Now, of course, that is possible because the same knowledge, for instance, here it's a logical function. Stop.
Excuse me,
Yes.
Marius. I think we are exceeding our time, so can we wrap up in a minute?
Yes,
Thank you. Thank you.
So you just see how the same information can be presented in many ways, and graphics are helping. Now in control engineering, I developed a method, but this is now very hot in this field, to work with surfaces, with control surfaces. Professor Jerry Mendel from California is promoting these methods. Now, my last idea is about the Bologna process. The Bologna process it's well known. Here we have the bachelor degree, which we are addressing first of all because here it's the most the scholar jobs are here. It's here. More present, and the master and the doctor degrees. And you see here the elite learning, teaching, and the mass teaching. I think, well, it's a radical opinion, but we think that most of the problems come from the fact that professors are trying always to use the elite methods and to show what they can and to impress students, and then in the end, they should. Some of them are leaving. We should change our minds and be aware that we must address the bachelor students at the mass level, which is not so bad because of course, it's not shallow, but it's large. And on the other side, it's including the job market. And you see here the generation Z, which are now students. They are different from the previous students. They are digital natives. They can accept much easier. For them, it's very natural to work digitally and visually. And I just show here some other methods. Well, they are not very, we never try to apply them, but there are just ideas. One of them is to try to teach
Marius, excuse me?
Yes.
We have exceeded our time, so...
Okay, I'm ready, you see?
Yeah, oh, thank you very much. Excuse me for that.
And I'm waiting for questions.
Yes.
I'm sure that people will there are people who criticize this approach and there are people who embrace it. So the discussion is hot usually.
Of course. Thank you. So yeah, we still have 1 minute for question and answer before Isabel. So do we have a question? Okay, Marius, thank you very much. I think we need more time to process the information. It's a huge cognitive load for us here. So thank you very much for your very fruitful presentation. Thank you.